Okay. Now the final thing is environment scaling. Environment scaling. So with, we'll go back to, let's do this one. All right. With Azure Container Apps, in this particular resource, we have a container and we have the number of CPU cores, the number of memory. And in order to change that, what we do is we create a new revision. Okay. And by the way, we do all this command line, but I'm just showing you. And we can select this, we can use this as a template, and we're going to check the same stuff, except we say, oh, you know what? I want, in the plan we have, 2 cores is the maximum we can give, and 4 gigs. Okay. And then we have some environment variables, which for example's sake, I'm leaving them as plain text right here. But if I hit save, well, now the Azure Container App is going to take my container. It is going to spin up another Kubernetes, within the Kubernetes pod, it's going to spin up another instance of my container that has 2 CPU cores and 4 gigs of memory. And then it's going to automatically do the VIP switching on the DNS and start serving requests to the running container that has access to more resources. That's kind of what it does. All right. So we don't need to save that. All right. This is how that works in Octopus Deploy. You have runbooks. Actually, before I show you that, I didn't show you one thing with the health check monitoring. There is a trigger that you can do. The runbooks. The unhealthy app alert. Now, I've made this application unhealthy, and I've told Application Insights in Azure. There's a few resources you stitch together when something fails. And there's a command line so that Azure calls out to my Octopus Deploy instance with a web service call and basically says, hey, run this runbook, because Octopus Deploy has all of my deployment logic and has access to my deployment packages. And that environment actually has more resources to maybe try to do some automated things to fix it, as opposed to what logic maybe you could have in Azure, like restart this, restart that. So you have some choices. If something is appropriate to be triggered in Azure, you can absolutely do it. But oftentimes it's a good pattern to trigger a runbook in Octopus Deploy, and then you can do whatever you need to do in that. Okay. Now, I have 2 interesting runbooks. One is called Scale Down Infrastructure, and one is called Scale Up Infrastructure. Let's look at the Scale Up Infrastructure process. Okay, right here. No, right here. Is this scale? Scale down. Oh, I wonder if I accidentally closed it. Okay. And this is the process. Scale up, yeah. Okay. So on this account, we are going to call scale infrastructure.ps1. And again, we have churchbulletin.script, which is our application. And it's looking for a file, scale infrastructure.ps1. And look at these app replicas. We're passing in container app scaled up replicas. How much CPU, container app scaled up CPU. How much memory, container app scaled up memory. And then the service objective is the DB scaled up performance level. So basically, on this other tab, we have the variables scaled, right? DB scaled up performance level is S0, and S1, 2, 3, 4, 5, 6. That's basically Azure SQL's performance codes. And then we have container app scaled up CPU memory replicas. So this application is nothing. We're scaling up the CPU from 0.25 to 0.5, but you can put 2 for scaling up, and then scaled up memory from half a gig of memory to 1 gig of memory. And then how many replicas? Instead of just running 1 container app, we're running 2 container apps. All right, so that's scaling up. Now, if you know that your users use your application during the day, there's no reason to have anything but the minimum running at night. And so if you're in education or non-emergency hospital or clinical, if you know, hey, look, these are the hours that people are using this application. We're not running Twitter here. We're not running, Hulu or any worldwide scale applications. For this particular application, it's pretty predictable what the usage patterns are. And by the way, most software has predictable usage patterns. It really does. We talk about the sexy ones that have to be up and have, 17 nines of uptime. That was a joke. That's impossible. But really, most software has very predictable usage patterns, and we don't need to overspend at night in the time zones when the users are literally sleeping. Now, maybe we want it to be up just in case somebody, is working late at night, unpredictable. And, okay, we scale it down, but it still works fine for 1-2 people. It's no big deal. But during the day, when we have our, normal 2,000 people or 10, whatever many people it is, we need to scale it up to a certain level and then scale it down. And just every day we're pinging it up and then down, up and then down, up. And just doing that pattern, we're going to save a whole lot in Azure cloud costs. So what does that look like? Well, we have those parameters being passed into scaled infrastructure.ps1. So let's go to Visual Studio. Again, we are externalizing from our DevOps tooling the actual logic for that environment. Why? Because this code is designed to be run in a particular shape of resource. Most of the time, we don't have a Visual Studio application and then we tell other people, oh yeah, one environment, run it on VMs, on another environment, run it on app service, in another environment, run it on Kubernetes or Azure Container Apps. No, most of the time we say, okay, I don't want anything environment specific in my code. What we really mean by that is I don't want the names of my environments. I don't want credentials to my environments. But the fact that this application is designed to be containerized, that tends to be very closely related to the code itself, okay? But again, that's a decision for you. So in this case, it's totally appropriate. This code knows that it's going to be containerized. No mystery, right? It was designed that way. So scale up infrastructure, we have app replicas, CPU, mem, service objective. Notice it has values because in our scale down, we just call this PowerShell script and we don't pass in any parameters. And so we have defaults. These are the scaled down defaults. And when we create an environment from scratch, we create it in the minimum acceptable to Azure. All right. Service objective is basic for the Azure SQL. And so, yep, we have a whole lot of comments for you to make it easy for you. But the real code is that we invoke web request, Azure CLI, MSI. We just start the process. Okay, that's standard anytime you're using Azure CLI. And then the real logic is to add the container app extension so that it's ready. Then we use our service principal. We do an Azure AZ login. And now we do an AZ container app update. This is going to create a new revision for us. And we give it the name, the resource group, because those are already available to PowerShell through environment variables. That's kind of automatic with Octopus. And then the max replicas, the CPU, the memory, okay? And now that one line of code is going to scale up the Azure Container App. The next line of code, AZ SQL DB update, this one is going to do the same thing and look, service objective, and it's going to go from basic to S1. And it's going to scale up from basic to S1. And that one line of code gives our Azure SQL database a little bit more juice. Okay. If we run this without passing in those parameters, then the defaults are going to take precedence, and then they're going to change, causing it to scale down. All right. And so when we go to triggers, we can see that at 6 p.m. on weekdays, we want to scale down everything, right? And at 8 a.m. on weekdays, we want to scale up. And that's it. It's as simple as that. It's as simple as that. And so we set up Octopus Deploy with the rule of, you know what, this is the schedule I want to scale up and scale down. But then inside Visual Studio, if we add a new component, if we add a second Azure SQL database for analytical reporting, an OLAP database instead of OLTP database, or if we add Azure Cosmos or something like that, and we have some other deployed component, well, all we do is we go in here and we add one more line so that that additional resource can scale up and scale down, and it works and it's done. We have fewer places to have to change some things.